A very good morning to all of you. I welcome you all in our today's session on Java 9 features. My name is Jasmine Kaur and I am a software consultant at Nolders INC Singapore. This is all about my company which gave me this platform to share my thoughts on this particular Java 9 features with you guys. So thanks to them. So our today's agenda will be Java 9 and its features, that is what exactly is new about, amazing about Java 9, that we are discussing everything about it in our today's session. How the Java 8 disadvantages got overcome inside Java 9. So there are a lot of features, but our today's main agenda will be focusing on Java Platform Modular System, which is commonly known as JPMS, under which we will be doing the comparison between Java 1.8 and 1.9, and then we will be going towards the modular structure. And then the second feature that we will be discussing in today's session is process API updates. So guys, a lot of new features have been introduced in Java 9, no doubt. As you can see, there is REPL, factory methods, interface private methods, modules, better process API, try with resources, better future, reactive streams, and many more. There were features which were already present inside Java 8 and got improved with Java 9's the release. And there are a lot of new features also that have been introduced. So we'll be going towards firstly the modules that comes under our Java Platform Modular System. That is a new feature that have been provided by Java 9, and then we'll be seeing the better process API updates. A process API updates which was already present inside Java 8, but now there is a lot of improvements which have been made, so we'll be going towards that. Java Platform Modular System, commonly known as JPMS. Guys, do you know the processing of this particular feature actually started in 2005, and finally in 2017 Java 9 people were finally able to accomplish this amazing feature. So you can see that it almost took them 12 years to create this particular feature. What does this implies? That there must be something special in this feature that it took them around 12 years. Do you know that even the release of Java 9 actually got delayed? That is, it was postponed because of this feature only. And if you want to go through the project which actually introduced this feature was Jigsaw, you can go through it after our session if you are curious about it. Okay, up till Java 8 everything was inside jar files, that we all are aware about, right? But in Java 9 there is nothing called as jar files, there is everything called as modules. So let's see what was inside jar file and what is in the module. Before we go towards the theoretical concept, I just want to make a comparison between 1.8 and 1.9 Java, which is present inside our system. So if right now I have both Java 8 and Java 9 in my system. So just before I move on, I need to make one point very clear, that Java 9 is not an LTS version. Java 11 is the LTS version. So when we'll go through the candidates of Java, we'll be actually seeing Java 11 instead of Java 9. So don't get confused and don't think that this session is not important because Java 9 is not LTS. Reason being, all these features of Java 9 have been present inside Java 11. So if you want to learn them, this is a good session to go for. Okay. So then let's go towards my system, and we'll be seeing the Java 8 as well as Java 9. So let's see the candidates of Java. You can see there is Java 8 and Java 11. So if I'll go towards Java 8 and I'll see the library, you can see that there is jar files which are present inside it. there is tt.jar, console.jar, there is tools.jar. I mean, all these jar files are there, right? But when I'll go back towards Java 11 and check the modules, there you go. You have roundabout, you can see this 70 items which are being shown. That is, I have 70 modules in here. So in today's webinar, we'll see the basics of Java 9, which actually become the backbone of Java 11. So moving on. Firstly, what exactly is a jar file? Jar file is nothing but a group of packages. What is a package? It is nothing but a group of .class files. So a .class file simply contains Java code, right? And what is a module? Module which got introduced in Java 9. It is also nothing but a group of packages only. And the packages, we know that it contains .class files, right? So it's confusing me. What is the difference? The first one is also a group of packages, and then there comes the group of .class files. The second one is also a group of packages which contains .class file. Why are we so emphasizing on the introduction of modules instead of traditional jar system is the question we'll be going to answer in today's session. Okay. Module contains a very special file that is called as module info.java. The world revolves around this. I mean, the world of modularity revolves around this particular .java file. So why is it so special? What exactly does it contain? Okay, I'll just forward my slide for few minutes so that I can give you an overview of the module info.java files, so that we can come back towards the comparison and you will have a better idea when I'll be talking about the comparison. There is the module structure. The module structure actually contains the name of the module. This is a module key which is used inside our module info.java file, and this is the name of the module. Module name is actually the name of the module, so don't get confused. If suppose your module name is module A, for example, you will be using module A here. This is the key, this is the name of your module. Inside this module info.java file, we have module name, and then we have a few more things. Here we can specify that what other modules we want. The first one is that. So suppose I have a few modules, module A, module B, module C, module D, and a lot of them. But my particular module requires just module A and B. So using this requires keyword, I can specify which module I want to use in my particular module. Therefore, according to this structure, my particular module requires module A and module B. Then there comes the second thing which we specify inside our module info.java file. What packages are exported by this module? Suppose this particular module of which we are seeing this module info.java file contains a lot of packages. There is pack 1, pack 2, pack 3, pack 4, and a lot of them. But I just want to export 2 packages towards the outside world. Rest of them I just want to have it for myself. So it's like making some of the packages public while rest of them are just private for you. So I can even export those packages. So that means only pack 1 and pack 2 can be used by the outside world. Rest all the packages that you have defined will never be able to, no one will be able to use them. You are not exposing them towards the outside world. Now this is the module structure of module info.java file. I'll be going back towards my slide of the comparison between Java 1.8 and 1.9. Now keeping that structure in mind, let's discuss the very first point. The first point is no class def found error. Guys, while doing Java code, you must have seen this error a lot of times. But when do you encounter this code? Does it happens during the starting of your project? No, but during the middle of your project. So suppose I have been using some class which is which my particular project is not able to access. So what happens when you compile the code? The compiler compiles, suppose the error is present at the 100th line, so all the lines before that 100th line got compiled by our compiler, and then after the 100th line it sees that yes, it is able to access a class which you don't have access to, and then bang, you got your no class def found error. What does that implies? That my resource got wasted for the compilation of those 100 lines of code, which at the end gave me an error. What if this can be improved, and beforehand only, that is before the compilation of those 100 lines of code, I can get this get this particular error? That is going to be a lot of resource saving, right? So this got actually resolved in a Java 1.9. How? I just show you the module structure, right? So suppose I'm using a class, and by the compiler will check that whether that class is present inside the modules that I have specified inside my module info.java file or not. Because at the beginning only I have specified that these are the only modules that I will be using. But in case my class which I am using is present inside any of these modules, it's fine. If not, it will not even start the compilation. So there you go. There you have your resolution. First problem resolved. Now comes the second problem. The second problem is version conflict. Now what happens when you use, when you work with Java 8, you have jar files, right? So inside jar file, suppose you have a same file with, the name of the file is same with the two different jars. What happens is you obviously gets a version conflict until Java 1.8. But with the help of Java 1.9, this also got resolved. How? This gets differentiated with the help of your module name. Whenever there are two classes inside two different modules with the same name, you can differentiate them with the help of your module name. Problem resolved. Second problem solved. Let's go towards the third one, security issue. Now, what is the security issue that we actually face until Java 1.8? You can see that suppose I need some class in Java 1.8, okay? Then what do I have to do? And that is present inside some other jar file. I have to export that whole jar file inside my project. That's a lot of things that you actually have to export, and especially with the help of modules, this problem got resolved, that you just have to specify the module that you want to export instead of using the whole jar file which got which was earlier being used in Java 8. So inside Java 9, just name the module that you want to use and you are good to go. But inside Java 8, you have to specify, you have to use the whole jar file. So there goes the security issue resolution. Then comes our bigger size. So the third point only implies my 4-point resolution. How? Then similarly, just like the third point, if you need a particular class, you have to export the whole jar file inside Java 8. But with Java 9, you can just specify a single module and then you are good to go. There goes the resolution for your bigger size. Modular structure we are done with. Okay, so before I go towards the what if questions about modularity, let's just have a quick demo of modules so that you can answer my what if questions. Okay, I'll be giving you a demo of how to create a very basic module, just to give you an idea. Okay, so this is my module, that is module A. That is the name of my module. What does this module contains? It contains a package and obviously my module info.java file. What does the package contains? It contains .java file only. So guys, this module, how does this module actually becomes a module is with the help of this special class. Keep in mind your module will never be called as module if you don't have this particular class. Opening this class to give you a brief introduction of this module, for which we already saw the structure inside our slides only. So this is the minimum requirement, guys, if you want to create a module info.java file. This is the minimum requirement. What do? We specify, use the key module and specify the module name. I told you that my module name is module A, right? So I specify the name of my module, and then inside this I can specify if I am using some other module and if I want to export my package towards the outside world. Right now I'm doing none of them, so I'll just leave them blank. So this is the minimum requirement of a module info.java file. Okay, now the pack1 contains a Java file, which is a very basic one, so it only contains a sysout statement for our demo purpose. But the thing that you have to keep in mind in here is you have to specify the package inside which this Java file is present. So the package keyword with the name of your package. So right now it's pack1, which should not be, which I won't say, suggest you guys to use the correct annotation for this particular naming convention for packages. Just make it something like com.noldes. But just to make our thing simpler and just to understand the concept of module, I have just specified it as pack1. So when you will go for your own projects, just go for com.noldes something like that. Okay, now what I'll do is I'll just run my module and see what actually happens. Okay, I'll compile this particular code and then I'll run the code. I'll compile the code with the help of my commands. I have already specified my commands. Just a second. Yeah, I'll explain you what does these commands actually means. So guys, Java C, we all are aware that it's the way of how you compile your particular Java code, right? Then there comes module source path. That is where exactly your module is present. If I'll go back and see, my module A is present inside webinar-java 9. So I have specified it webinar-java 9. Then -t is the flag after which you specify that your compiled code comes in which particular folder. So right now it's out, which I have just named, and then -m is the flag after which you specify the module that you want to compile. Let's run it. That means my Java code has been compiled. Okay, you can see now we have a out folder which has been created. I'll just show you the tree structure of the original code and the compiled code. Okay, webinar.java and my module A. Let's see the tree structure. So you can see inside module A what we had was module info.java. We had our package, and inside the package we had our Java file that I already showed you. Now I'll be going towards my compiled code. So let's see the tree structure. So now the module A contains module info.class file, not Java file but class file. Then there comes pack1, then there comes test.java, and here comes the test.class file. That means yippee, my code is compiled. Now I'm all ready to run the code. And what is the expected result? What is the expected result? It's just the sysout statement which I have specified. So oops, I'll just show you again. The sysout statement which we are expecting is specified inside this Java file. That is our first module based application. Using the command to run my Java code. Now what does this command means is, Java means the command which is used to run our Java code. Module path, now the module path will be out because that is the compiled code, and then my module's name and the class, the package, and then the class which I want to run. Oh, module A. Oops, I need to go out. There you go. Our first module based application. As expected, we have got our expected outcome. So we are done with the creation of our basic module. Moving back towards the slide, what if questions. I'll be asking you 3 very interesting what if questions. So I would recommend after my question you pause the video, give it a thought, and then go towards the answer. My very first question is, what if I remove this particular module info.java file? Will my code get compiled? Think about it. I'll just delete this one so that now if I'll try to compile my code, I'll copy it and paste it here. So you can see inside module A, there is nothing as module info.java file right now. So now I'll try to compile this particular module and see what happens. Do you think it's gonna compile? Think before you start this particular video again. No, it says that module A is not found in module source path. Why? Guys, remember I told you that this module is actually called a module because it contains module info.java file. So that is the first thing that you have to create when you start working with modules. I'll be pasting back my module info.java file in this module to make it correct, and moving on towards my next what if question. My next what if question is, what if I remove this package name? I'll save it. What do you think it's gonna do? Will it compile my code? Give it a thought. No, it gave me an error. What does it say? That unnamed package is not allowed in named modules. That means it does not understand that which package do I belong. Where is my package? I'm simply a class without a package. That is not allowed. So I'll just paste it back. Now comes my third question. So my third question is, what if I just change the name of my module A, rename it to something like module 1. Earlier it was alpha, all alphabets. Now I just want them some numeric numbers to be introduced. And since I have changed there, so the thing which I have to do is update the name inside my module info.java file as well. Point to be noted. Now I'll compile my module. So I have to change the name of the module here as well. What do you think it's going to do? Give it a thought, pause the video and resume it back. It will compile. It gave me a warning, but it got compiled. The warning says that it should avoid terminal digits, but it will compile. So it's something like the annotations, like, right, I mean, what you should do and you should not do, but it won't stop you from creating a module. You can see that the out folder is created, and if I'll try to run my particular out folder, module A, it will give me the expected result, but this is something which should be avoided. So there goes my 3 what if questions. I hope you enjoyed that and get something to understand with these questions. Okay, moving on towards the next slide. Process API updates. Guys, do you know, when modular system came, Oracle people thought that this is their biggest achievement. But when I talk to the people who are actually using Java 9, for them it was not modular structure but process API updates which helped them a lot. So a little background before we move forward is that the process API updates was already there. So there will be some of the new features and some of the features which were already present and which got improved with this Java 9 introduction that we will be discussing. Now, what if I want to develop something called as, like a device driver software or an operating system? That is, for system level component until Java 8, it was not at all suitable. Reasons. First one is the communication process with Java was very, very difficult until Java 1.8. Java 8 was, until 8, it was not at all a machine friendly language. So, if you want to communicate with the processes, you had to write kilometers of code, and most of the code was native code, not even written in Java, and you have to use a lot of jar files. Therefore, until Java 1.8, the communication with the underlying processor was very difficult. The way the process management handling was done also varied from operating system to operating system. Example, Mac had their own way of handling them, Windows had their own different way, Linux had their own different way. But now 1.9 Java made this feature so amazing, you're gonna love it. It is so easy. So when you started writing Java code when you guys might remember when you started writing your Java code, right? What was the first program that you wrote? For me, it was Hello World. I think it was for most of the people, right? You remember now how much simpler is it? That is the amount of complexity which is used for our process API updates. Or rather, I should just slash out the complexity and say the simplicity, right? So that much simple is our process API updates now with the help of Java 1.9. Okay, so there comes the process API updates that we'll be going towards. We'll be seeing the process ID of the current running process, which was already there, but now the mechanism is extremely simple. Earlier there was a lot of code which was involved. Now it's to the point how we'll be seeing everything. Okay, now the second one is how you can create a new process. Example, open a notepad. You will say that we can open a notepad using GUI. Agreed. But what if you want to do something with it while you are coding, while you are writing a Java code? I'll show you how you can do that. Or maybe if you want to compile a Java program, you can say that I can go to command line and just specify the command. But now what if I want to do it with the help of my Java program? Now these things have become very simple. We'll be going towards the demo as well and seeing both of these features being done with our new Java processor. How you can destroy the already running program. For example, you want to close a notepad. I know you can do it with the help of GUI, but how you can do it with the simplicity and with the Java code is our today's agenda. And how you can stop a Java program with the help of another Java program. Then there comes how you can get a complete information about a process, how you can get complete information about a child process and parent process. All these things have become very simpler now. Okay, so before I start towards this slide, so these are some of the four features, and the point to be kept in mind is that the order may vary when I'll just start with the when I start with the demo of all these features, because I'll be mainly focusing on how one is interdependent on the other. So according to that, I'll be proceeding towards the order. There are a lot of features that have been introduced by Java 9 Process API. The first two are the old ones which have been enhanced, and the second two are the new one. The first one, that is process class. Now there are several new methods that were added inside this particular class, like PID info. Process builder. This is used to create your own operating system processor. How we'll see. Process handle interface. This is a new feature that Java 9 has provided. It is used to handle the processes like access the current running process, access a parent process, a child of a particular process, and so on. And then there comes the process handle.info. This is actually an inner interface inside this process handle interface, and it is used to provide you the complete information of a current running process. The node specifies is it's something interesting that all these classes interface are present inside Java lang.package. So there is no need to worry about any of the import statement, because we all know that java.lang package is a default package that is already imported. Okay, now let's go towards the next slide. Now process API updates how to handle the objects. There are three ways. Maybe you want to handle the current running process. So what you have to do, you just have to create an object of handle, that is process handle.current, and then with the help of this handle you can handle your process. How? I'll show it to you in a bit. Then you may want to handle the process which is already running. I mean, you have created a new process and now you want to handle that. So what you have to do is just specify the instance of the process and use the toHandle method, and then you have got your handle, and with the help of this handle you can access all the amazing features. Then there comes a third one. What if you have a PID of a process? With the help of that also you can get the handle of your process, but that will obviously provide you the answer in optional, because that PID may or may not exist, right? Okay, now we are done with the theory part, and just one more slide maybe. Yeah, process handle.info, which was an inner interface, will actually provide you the information snapshot about a single process and multiple processes. Okay, and then there comes the process builder. This class is actually used to make the operating system processes. Then how? So you can actually use a process builder and have a new keyword just in order to create a new instance and specify the command for which you want to create a process for. So for instance, suppose you want to run what if you want to start a notepad, and if you are in Windows, so how can I do that? I'll specify new process builder, and inside the command, which should be a valid command, I'll specify notepad.exe if I'm using it inside the Windows. So that is the command which actually helps us to start the notepad process. And then you have to just specify the start, and you can get your process and do whatever you want to do with it. Okay, now enough of the information on the theoretical aspect, and let's spice things up with the demo part. Okay, so the demo, firstly we'll just see that how we can actually go for the process handle. That I will show you with the help of JShell. Okay, so what if you want to handle your current running process? You all know that Java 11 is currently running in my system. Okay, so what if I want to get the information about Java 11, my process Java 11? What I'll do is I'll specify process handle dot current. This will provide me the handle for my current running process. So with the help of my handle object, I can use the info method to extract the information of my current running process. You can see that the username is optional of Noldes. The command which is used for Java 11 is this one. These are the arguments. There comes the start time, there comes the total CPU duration total time which is being used, and many more. So this will give you an overview of all the information. But what if you just want a particular information? Maybe what you can do is handle.info. I'll just create the object for info, right? So with the help of info, I can maybe extract user of my current running process, or maybe I want to have the current CPU duration. So you can see there are a lot of options which you can use. Suppose total CPU duration. You have got your total CPU duration for the current running process. So you can see that how we can get the access of a current running process. Now how you can get the access of a particular process for which you have a PID. You can do that as well. Just have to specify process handle dot off, and inside this let's extract PID of some process which is running, maybe Chrome. The PID for Chrome is 14025. So let's specify 14025. Let's get the handle, and you can see the return type is wrapped inside optional because this value PID may or may not exist. I have got the handle. I have to apply the get. I have to apply the info. Oops. What wrong did I do? Oops. Yeah. So you can see that I have got the info. Now let's create the object for info and extract maybe some particular information. Info dot, what do you want to extract? Command. Okay, let's go for command. There comes opt, Google, Chrome. Something else, user. Let's extract user. There you go. I've got your optional user. So this is how you can actually use it to extract the information of a current of a process for which you have the PID. Now I also told you that we can extract the information not just of a single process but of multiple processes as well, right? So how we can do that? Let's have a look at that. For that I have already created a program for you guys in order to make our thing simpler. So you can see that I have a process handler stream here. I have extracted all the processes which are currently running. Okay, now for each of the processes I have extracted PID, user, command, CPU duration, start instant. So I'll quickly run this particular code. I already have a command for that to run this particular Java file. So let's run this. There you go. You can see that these are all the processes which are currently running, and I have got the values for PID, user, command, CPU duration, and so on and so forth. You may want to use any of the features for stream because this is actually giving you a stream. So maybe a map or maybe a restriction that you just want the first two processes or anything that you want, you can apply that as well. So you can see how simple is it. Now what next did we learn? We learned that you can use a process builder to make up operating system processes. So for that we have a demo. There you go. It is actually using a frame demo.java file. So what does this file actually contains is it's a GUI code. You need not to worry and go into details. I'll just explain you. This demo of just creates a frame with the help of Windows adapter. It does nothing but set the size, add a label, and set the visibility to true. Okay, so this is a Java file that we will be running and then we'll be destroying with the help of another Java file using the process builder that we learn. I'll just specify inside the process builder. What do you have to specify? You have to specify the command which is used to run my Java program, that is Java only, and then you have specified the path for which for the file that you want to run. And after the process gets started, you just are specifying a sysout statement, and then you will sleep, you will make the system sleep for 10 seconds, and after that there is a sysout statement, and then you will simply destroy the process. That means I should be able to access this particular frame demo.java file with the help of this particular class, and this class should be able to start my process and destroy it. Let's run it. This is my command. This should create a frame. You can see the sysout statement, you can see the frame. After 10 seconds it will get destroyed. I am not touching my mouse or keyboard. You can see that it got destroyed itself and the sysout statements have been displayed. So the process with this PID got started, and after 10 seconds it automatically gets destroyed with the help of our Java code. So one Java process is able to access another Java process. Can see these amazing features that Java 9 has provided. Now we have seen that how one Java program is using another Java program. Now let's see how one Java program is able to access another non-Java program. You can even do that with the help of my process builder only. You can do the creation and destruction that we studied. Let's do that. Okay, so I'll be using some other Java program, and for that I'll be specifying the PID in here, and there is a sysout statement that is after 10 seconds we'll just destroy it. So maybe we can open the postman and extract its PID and then destroy it. My postman is open. Go to system monitor, search for postman and the PID. So the PID for postman is 666. Okay, let's just specify here 666. This is the PID. What it should do, it should after 10 seconds it should automatically close the postman. So let's just copy the command to run my particular Java code, which will automatically start close the postman after 10 seconds. So so this is my postman, and no touching of my mouse or keyboard. After 10 seconds it will get destroyed. There you go. I didn't touch anything, it itself got destroyed just with the help of another Java program. So guys, now I think you have learned a lot how to interact with different Java programs with the help of your own Java programs, and saw the simplicity it is there, which was there. The complexity is very little, right? So I hope you have learned something with this session and demo. We are done. These are my references, and if you have any doubts you can just mail me at jasmine.kaur@noldus.com. Thanks a lot. I hope you have enjoyed this session. Thank you for your time and patience.